So for today, we're going to have a short review on the topics covered for Endterm in preparation for your exams on January 3 to 6. Okay, so as a reminder, I'd like to remind everybody that your exam is not comprehensive. So it's just covering the topic on midterm, rather Endterm topics, not everything. And your CLE, your culminating learning evidence, the final requirement that is to be submitted on January 6th should be submitted on the date that is specified in the instruction. The list of failure is required from us January 9th. So it's really very short. It's a short notice from the usual practice wherein we have the exam and then we're given 2 weeks to submit your grades. In our case, we are asked to submit the list of failure, which requires that all assessments are checked already, all requirements are checked already on January 9. So we're only given 2 days after the last day of the exam to comply. So please submit. This is recorded, so please submit. I will not anymore have the deadline extended. So I will be able to compute the grades in time for the submission of the list of failure. Okay. Let me check. A participant has enabled closed captioning. What is this? Anyway, I will now share my screen. The items that I'm sharing with you here are already items given in all classes. So it could be given in the CHE, it could have been given in the COE class or in the ECE class. So anyways, it's just a review, so you will have an idea on how your quizzes were supposed to be answered or whether you have answered the correct thing. Okay, so I'm going to share it now. Check. So this is an item given to one of the classes, and you have here a third order DE. It's non-homogeneous because the right side is your g of x is not equal to 0. Now in here, you need to find the roots of the auxiliary equation, which requires you to use the coefficients of the derivatives of your unknown function. So all the terms here are complete. You have the third order derivative, you have the second order derivative, you have the first order derivative, and the unknown function. So you have to copy the coefficients, and I'm using here synthetic division. Okay, this is a trial and error thing. So when you do it, you can use your pencil initially, but if you have your calculators that can do this right away for you, so much the better. Now, it came out here that the roots of your auxiliary equation is 2, 1, and 3. So your YC, in this case, the complementary solution is C sub 1 e raised to 3x, C sub 2 e raised to 2x, and C sub 3 e raised to x. Now, it need not follow this order. It could be in any order as long as all the roots here, which are real, are accounted for. So if the roots are real, you know that it would be written in the form of an exponential function whose argument is the said root. So if you have 3, 1, and 2, so you have here 3x, 2x, and x. Now for your YP in this case, since this is exponential, the form of the particular solution is this. So you copy the exponential function and you have the coefficient here 2 replaced by a. So you need to determine this a. Now, this method of solving this non-homogeneous higher order DE is the method of undetermined coefficients. Okay? Now, you see that your DE has until the third derivative. So you need to get the derivatives of your unknown function as well up to the third order derivative. So this is your unknown function form. This is the first derivative. This is the second derivative. And this is the third derivative. All of this will be substituted to the original DE. So you need to substitute it here. And you would need to copy the g of x on the right side. So that's done in here. Okay? We substituted the derivatives to the left side of this DE. So you copy the coefficients and you multiply them with the derivative. So this is what you'll have. And since all your terms have e raised to minus x, you can cancel those functions, leaving you with terms that has the a and the constant 2 at the right side. So your a here is negative 1 over 12. Then that tells you that your YP, your particular solution, which should not contain any undetermined coefficient, is negative 1 over 12 e raised to negative x. So you substitute the a here. And your complete solution would be this one. The sum of the YC and the YP. Any questions so far to what was shared here as to the solution of this one?
None.
Okay, so if there's none, we'll go to another one. Okay, we'll pick another one. This is a quiz which requires you to write the form of the particular solution, and for the first part and on the second part, you are required to write the complete solution. A lot of the students here that made the mistake really doesn't probably understand the instruction. So the instruction simply says that you are to write the form of the what of the particular solution. So the reason why they're not able to reach up to part 2, that is test 2, is that they really determine the solution of the entire thing, which is really impossible knowing that you're given only an hour and this is the form of the particular solution which is being required. So that's just the form, but you need to determine first the YC. So that would really entail so much time. So it's really very important that when you take any form of assessment, you read the instruction. If you do not understand the instruction, you ask questions. Okay? So the reason why this quiz, even though it's really procedural and in my opinion easy compared to the other quizzes that you have taken so far, is a lot of you were not able to make it. It's because you do not know how to follow instruction. You do not understand the instruction and you don't ask questions when the instruction is not clear to you. So let's say, for example, you are given y double prime plus 6y prime is equal to 3 e raised to 2x sine of 2x. You have an exponential function multiplied to a sine function. Now, if it's just a sine function, this is the form. The a sine 2x plus b cosine 2x. This is the form. But since you have the exponential function, you need to multiply it with the exponential function. The exact thing. So you have e raised to 2x times the form of the particular solution for the sine of 2x only. Now, most of those who did not really get the full points here is that they place the undetermined coefficient here on the e raised to 2x. No, you don't write a e raised to 2x, then sine 2x plus b cosine 2x. You don't do it that way. You place the undetermined coefficient on the sine and cosine function, and no coefficient or undetermined coefficient is written before the exponential function. So this is how it should be written. As easy as that, and you get the full points here. Now, for the second number, you're given a third order DE, and the right side constitute a product of x cubed and the cosine of x. So this cosine of x already tells you that you will have two terms, the sine and the cosine. If you don't have the x cubed, you will simply have the a cosine x plus b sine x. But since it's a third degree polynomial, the ordinary a and b should be replaced by the form of the particular solution of this third degree polynomial. So now the form of the third degree polynomial is ax cubed plus bx squared plus cx plus d. That's covering only for the undetermined coefficient of the cosine. For the sine, it should have its unique third degree polynomial form of coefficient multiplied to it. So you should not write ax cubed still in here. It should be ex cubed plus fx squared plus gx plus h. Okay? So you replace the a and the b in the standard cosine form of the particular solution by the form of the particular solution for this third degree polynomial. I don't know, some students, I could still remember, they write ax cubed plus bx squared, and there's no cx and there's no d. I don't know why is that, because you need to complete all the forms, even if you only get to see here an x cubed. So you have to complete all the forms starting with x cubed, x squared, x, and d. But if naka-substitute, miss, ang expo sa terms may points lang, miss. What you mean? I can't understand. But if naka-substitute ang expo sa terms,
Miss, though wala miss ang wala naka-quantity, wala miss ang a sine 2x plus b cosine 2x, naka-substitute ya ang exponent.
Gin-distribute mo, not substitute. Gin-distribute mo na ang e raised to 2x.
Oo, miss.
So ang gwa, a e raised to 2x sine 2x plus b e raised to 2x cosine 2x.
Oo, miss.
Okay na siya, correct mo na siya gyapon, din factor out na siya dire. Okay?
Thank you.
Sige, sige. So any question here on number 2 and the form? If you have distributed the multiplier class to the thing in which it is multiplied to, it's okay. But it's just a tedious thing because i-kopya mo pa siya. There's no need to copy, you need only to write it. But if you have distributed it, it's okay. Now for number 2, any question here? I have noticed as well, by the way, in number 2, probably in some sections, the argument of the sine and cosine are actually being copied in tuto. What I mean in tuto is whatever is the argument of the cosine here, that should be the same argument of the sine and cosine that should be written in the form of your particular solution. So some did not even copy correctly the arguments of the cosine or sine function. Okay? Sige. Wala questions sa number 2? Sige, we go to number 3. And there were some students who approached me after the class how it should be written. When you write class A polynomial, it need not be always written in this manner, that you start with the term with the highest degree of exponent down to the constant. It could be written as well like this. Okay, so this is just a first degree polynomial multiplied to an exponential function. So you copy the exponential function and you multiply it with the form of the particular solution of the first degree polynomial. Or, just like what Jabel is saying, you could substitute the ax e raised to 3x plus b e raised to 3x here. That's okay. But if you write it simply like this, it's even okay because it's easier to correct. Okay? So it's just a first degree polynomial. Your 3 minus 36x is a first degree polynomial. Any questions? Okay. For test 2, I really made sure that the time that you're given, that's an hour, could be enough for the 5 numbers. So I gave you a homogeneous higher order DE in test 2. That way, your solution will simply require the roots of the auxiliary equation. So you use, in this case, I'm not sure if your calculators can give you up to the fourth root. But in this case, this is how you use synthetic division. So your roots, your real roots, constitute of 3 and -3. Okay, I need not spell out what synthetic division is. And this one requires quadratic equation. So you can also use your calculator for that. But your roots, your pair of complex conjugate roots are 3 plus 4i and 3 minus 4i. And we have discussed that if you have a complex root, the form of your complementary solution that is, will use the real part as the argument of the exponential function and will use the imaginary part as the argument of the sine and cosine function. Okay. Sige. So fine with, so that is good for you because then you will have less time. You have more time to tackle the other numbers. So if you have if your calculator can do it for you, just make sure that you know how to do it yourself. Not rely on your calculator. But that is the case. It's really it's a shame if your calculators know how to do it, but you don't know how to do it. Engineering students should know how to do it by hand. Okay, so that's it. That's your root. So this would be the 2 real roots. So c sub 1 e raised to 3x plus c sub 2 e raised to minus 3x. And this will account for your pair of complex conjugate roots. Again, the placement of the terms need not follow this order. So you can have this first written, then followed by these 2. As long as you have all 4 terms with their undetermined coefficients. Now, undetermined in the sense that you are determining here the complementary solution. There's no particular solution because you have a homogeneous DE. You only get to have the value of C1, C2, C3, and C4 if you're given initial conditions. And what are these initial conditions? So the y prime of 0, the y double prime of 0, the y triple prime of 0, those things. So those should be given. That way you'll know how or you'll have a way of knowing C sub 1, C sub 2, C sub 3, and C sub 4. I remember there is this mistake done by some, not all. The coefficient here in the cosine and sine is taken out and it's written here. It's not that. You write the coefficients here. Okay, you don't write the coefficient in here. Remember, if you have until 4th order derivative, you are to reflect 3 undetermined coefficients in your answer. Okay, you have 4, so you should also have 4. So if you write the C sub 3 in here and no coefficient is written here, that does not conform to the rule that your complementary solution should have the number of undetermined coefficients equal to the order of the given DE. Okay, so some of those who made a mistake here place the coefficient on the exponential function and no coefficients here on the cosine and the sine. So please remember that it should be written here, not in the, it should be written here in the cosine and the sine, not on the exponential function. Okay, the second item that I gave, I'll just close this one. Is this. You have the third derivative minus 6y double prime plus 11y prime minus 6y equal to 2e raised to negative x plus x. So I modified it in the sense that in that particular first item I discussed, I only reflected the 2e raised to minus x, but this time I added the x. So the same thing, since this is non-homogeneous, you first find the roots of the auxiliary equation. I made use of synthetic division, telling me that I have 3 roots here, 1, 2, and 3. And if I write the form of the particular solution in just one setting, I should account for this exponential function. So that should be a e raised to minus x. And I should also account for this first degree polynomial x. So that should be bx plus c. Then since I have until the third derivative, I need to get the derivatives of this form of my particular solution. Now, if you did it piece by piece, like you only had this first followed by this, it's fine. But in my case, I want to shorten the solution, so I have placed it everything here. So the answer would still be the same if you do it piece by piece. So your first derivative would be this one. Your second derivative would be this, and your third derivative would be this. What happens is you substitute the 3 derivatives and the form of your particular solution for your unknown function on the original DE. So you copy it, place it there, substitute, and copy the right side. Okay? Now after that, you equate coefficients just like the way we do it. So if it's e raised to minus x, you will have to copy the coefficients of those terms that has e raised to minus x. So this is what you'll get. If it's for the x, you'll have the b here and you'll have here 1. And for the constants, that's your x raised to 0. Excuse me, class. You'll have your constant equal to negative 11 over 36. So the constant on the left, which is 11b, and negative 6c was copied here. There's no constant on the right. So it's 0. You substituted the b here and you'll have the c equal to negative 11 over 36. So you have already the 3 undetermined coefficients, a, b, and c. You go back here and substitute it. So this will be your yp. Your yc will take care of the roots of the auxiliary equation, and your complete solution will be the sum of the two. Okay? Any question here? So no question here. Okay, we'll have the last two. This is in the case of the use of the operator method or the exponential shift, whichever method you used. This is, I think, the same quiz I gave to both CPE and COE. Now, your operator here on the left side, the D, is D squared plus D. Okay, and you have the Y and you have 2e raised to 2x. This could be solved using exponential shift. Some used exponential shift and they did it correctly as well. In this case, I just used the operator method. That way you get used to seeing solutions using the operator method. Because exponential shift is just an innovation or a modification of the method of undetermined coefficients. So we'll have a different take on this. Since you have an exponential function here, make sure that first, your operator here on the left is factorable before you even try to integrate this one, depending on the formula that is appropriate. So you have to start with the 1 over d plus 1, or you can start with the d, meaning you integrate first 2e raised to 2x. It depends on you on what particular d will you process first, the d or the d plus 1. So if it's the d plus 1, the 1 over d plus 1 tells you that your a here is -1. So in terms of the formula, or your p is -1, it's e raised to -x integral of e raised to x. Then you copy your function of x here dx. Remember, I did not notice rather that I did not place the d here. I don't want to have a very long line of solution here, and I want my solution to be organized. So I did not place so many d's first. So I only place the d in here that I'd like to process. You can do that, but if you are the type that you'd rather have everything on the right side, that's fine. Okay? So you have to multiply these two first before you're going to integrate. So in this case, you multiply first. So some had the problem of not knowing what to do first. So some multiplied first, then integrate. Some integrate first, then multiplied. So what you're going to do first, the correct thing is you have to multiply first. So multiplying gives you this, and of course gives you the integral of e raised to 3x, which is 1/3 e raised to 3x. You need to multiply it with the constant 2. A majority forgot all about 2. 2 cannot be written anymore cannot be seen anymore in their solution. I don't know why is that. So after you have processed the integral, you multiply it with this e raised to -x. So it becomes 2/3 e raised to 2x. Then that's the time that you place the d in here on the right side in the form of an inverse operator, which tells you or requires you to integrate your function of x here. So since I have a constant 2/3, you write it before the integral, and you integrate e raised to 2x. So that would give you e raised to 2x over 2. Then multiply it to 2/3, so that would be 1/3 e raised to 2x. If you do the method of exponential shift, this is the same particular solution that you'll be getting. Okay, I think I have two students who used exponential shift here instead of operator. For the y sub c, the complementary solution, it's simply based on this one. And a lot of my students doesn't know how to factor d squared plus d. I don't know why you have a d squared plus d. Some would factor out d squared and they will write something here. Some will have a d minus something. I don't know what's wrong. I don't know what's wrong with the algebra. But this is the proper way of factoring d squared plus d. So telling you, kindly mute yourselves, please. Telling you that your roots are 0 and -1. So 0 and -1. So if you have 0 and -1, this should be the form of your complementary solution. Your complete solution would be this. Very easy actually. Why? Because you simply have an exponential function here. It would be a lot cumbersome if you have a variable here. And that would be illustrated on the next example. You have any questions here in the solution here? Is the solution clear?
Yes, miss.
Okay, we'll have this close and we'll have the next one. The last. Okay, again, here you have the operator d cubed minus d times y equal to x plus 1. Again, majority of the papers that I did not even bother to check what is written below is the problem with factoring here. So that problem will be with you until you graduate, until you know how to factor, because that factoring thing should have been mastered in algebra. This is how you properly factor d cubed minus d. Common factor is d, not d squared. A lot place, the common factor is d squared. So it should be d, giving you here a multiplier, which is d squared minus 1. And this is also factorable. It's d minus 1 and d plus 1. So these are your three operators in factored form. Now, if you intend to use operator method class, no matter how easy the right side is, if you intend to use it, just make sure that your left side, your operator D or your f of D expression is factorable. What we mean with factorable, it should have real roots. If the roots are imaginary or complex, you cannot use the operator method. So in here, I used again the operator method. So if you have, if I may suggest, since you already have the x here, don't start with the 1 over d or the inverse operator, because it will increase the degree of the x. It will become x squared. And later on, when you have it integrated together with an exponential function, due to this d minus 1 and d plus 1, you will need to integrate by parts twice. So that would be really very cumbersome. So I suggest you first start with any of these two. Any of these two will do, and just integrate it using the inverse operator. Okay, so if you do it like this, pwede man suli, 1 over d plus 1 and times 1 over d minus 1, doesn't matter. But if you do it like this, your first p is 1. So you have e raised to x and e raised to minus x. It's always like this, class. If this is positive, here, before the integral, the exponential function after the integral is negative. So positive or e raised to x, then the next e will have a negative exponent, e raised to negative x. So I'm referring to the exponents, by the way, when I say positive and negative. This accounts for the 1 over d minus 1. The 1 over d plus 1 tells you that your p this time, so if this is your p sub 1, your p sub 2 is negative 1. So you start with an e raised to minus x integral of e raised to x. Since you have two integral signs here, it follows that you will have two differentials here because you need to integrate twice. You just simply copy the function of x here, which is x plus 1. Now, what I did first before I even start integrating is I simplified what I can simplify. So simplify. So you have e raised to minus x times e raised to minus x. That's e raised to minus 2x. And I have this, right? So still two differentials. The e raised to minus e raised to x here is copied. So this one is equivalent to the integral of x e raised to x plus the integral of e raised to x, because in this case, you need to distribute the exponential function here. Like that. So this is the two integrals, the resulting two integrals. We don't have a problem with the second integral because that's integrable, but this one requires integration by parts. So if you do integration by parts, this is the answer. Okay? X e raised to x minus the integral of e raised to x dx. And I copied this one. So I canceled the two because one is negative, the other one is positive, giving me a remaining x e raised to x, which is the answer of this integral, which before integration, I need first to multiply with e raised to 2x. So you see here, it's e raised to minus 2x times my answer here, which is x e raised to x. And I have here the differential of x. Now what happens is this. You will now multiply these two. You will have x e raised to negative x dx. Another by parts here. So this is the way you do it. And since this is negative, instead of a negative integral here, that would be positive. So this is the first part of the integration, processing the 1 over d minus 1 and the 1 over d plus 1. but you still have a D here. So you need to transfer it here on the other side, telling you that you need to integrate this. So see how easy it is when you just need to integrate your negative x minus 1. So this is your answer, and there were a lot of students who got this one. Before you do this, make sure that you simplify first this one. So the integral of this is negative e raised to negative x. If you multiply it with e raised to x, that would be negative 1 because your e will be now raised to 0. This 1 multiplied to this will give you a negative x. So you have this, and that's your integral. So this is your yp. Your yc is very easy because it's just based on the roots here of your auxiliary equation. You have a 0, a 1, and a negative 1. So your yc will be this. Your complete solution will be this, the sum of the two. So whenever you see a variable on your right side, if you intend to use the operator method because the f of d is factorable, you always use the d minus p or the d plus p first, followed by the 1 over d last. Because if you first do integration with your function, it will increase its exponent. So you will have difficulty here in by parts. Okay, so always do this first. Okay. Now, any questions here? Any questions here? Wala gid na difference. Kung let's say for example, ang ginuna tanga P1 si D inuna tanga process is rather 1 over D plus 1. So mauna ni siya ang e raised to negative x followed by e raised to x. Wala gid na siya difference. Amo lang na gyapon ng answer. Pero wala man na diferensya even if you start with the 1 over D. Kung ginuna mo siya pero maayawan ka integrate. Kaya ma-x squared man ni siya, ma-x niyo, yawan ka by parts. Kaduha ka mag by parts sa diri nga term. Sa diri nga term, ka isa, ka ma-x na ni siya. Ti how many times will you do it? Kay duha ni nga daan ka bilog. So 6 times ka mag by parts kung unahon mo si 1 over D. So always start with the 1 over D minus P or D plus P. If the right side contains a variable, any questions? Okay, I will pause the recording for a while and get a DE which we can solve using Laplace transform. How I solve one DE using Laplace transform. Okay, we'll try this DE. We'll solve it using Laplace. Okay, so that's our DE. A second order DE. The right side is a combination of an exponential function and a second degree polynomial here. Okay, so we will use Laplace in this case. So I will take the Laplace of y double prime. I will take the Laplace of y, not forgetting that the 4 exists. And I will have 15 Laplace of, I will change the x to t. So you will know how to easily get the Laplace. Later on, I will just change it back to x. And I will have here Laplace of t squared. Although you need not really change it to t if you know how to apply the formula, even if the variable is x, just mentally switch it to t. Now for the Laplace transform of a second derivative, you have this. And that one will be for y of s. Laplace transform of y is y of s. This e raised to t has a Laplace transform of 1 over s minus 1. So exponential function is s minus alpha, whatever is the alpha here. Then we have an e, then the Laplace transform of t squared is, our n here is 2. So this is 2 factorial over s raised to 3. I will assign a value to the conditions in a while. Okay, so you have this. Now, by the way, you can use Laplace transform only if your DE is provided with initial conditions. In this case, I will place here the initial conditions that you need in the problem. I will just place it all to 0. That way it would be easier. So your y prime of 0 and y of 0 is 0. So in this case, this will be 0 and this will be 0. So your left side remains to be s squared y of s plus 4y of s. And you simplify what you have here on the right. So you combine this into one fraction. So if your LCD is written, it should be s cubed and s minus 1. Then this 15 should be multiplied to s cubed. And this 8 times 2 factorial, which is 16, should be multiplied to this. So 16 times s minus 1. If you factor out y of s here on the left side, you will have s squared plus 4. And in here, if you simplify the numerator, you have 15s cubed minus 16s plus 16. The denominator is s cubed s minus 1. So as discussed, for you to be able to find the solution of this DE, you need to isolate the y of s on the left side. That way, you can also have it inverted later on. So we will do that on the next page. You may take a screenshot here so you can follow through. So this is our last line here. We will isolate the y of s in this side. So you need to divide the entire equation by s squared plus 4. So your resulting expression would be y of s equal to, so you have one long denominator here. You have s cubed, you have s minus 1, and you have this quadratic factor s squared plus 4. So I chose this, that way you will know how to invert later on. And you have the numerator 15s cubed minus 16s plus 16. Okay? So this tells you that this will be this should be inverted. That way you can get the y of x, which is the solution of your DE. So we'll go to inversion. So inversion requires method of partial fractions. So you need to help me out here with the equations. Unless otherwise you can manage on your own to determine the undetermined coefficients. So when you write your partial fractions, this is a repeated linear factor. So you have an s, you have an s squared, and you have an s cubed. This is just one unique linear factor. So you have s minus 1. And you have here a quadratic factor. So that entails you have one which is an s, and you have this one. This is s squared plus 4. So you have a quadratic factor requiring that the numerator should constitute two terms, one that has an s and the other one which is a pure undetermined coefficient, which you will determine in the first place. Then you copy what you have on the left side, the numerator only, and these undetermined coefficients or coefficients that you need to know, determine, should be multiplied to the factor that is not or that is missing in its denominator. So your A should be multiplied to S squared, S minus 1, and S squared plus 4. Your B should be multiplied to S, S minus 1, and S squared plus 4. Your C should be multiplied to S minus 1 and S squared plus 4. I'll place here the D. The D should be multiplied to S cubed and S squared plus 4. Your ES plus F should be multiplied to the factor that's not here, which is S cubed and S minus 1. So whatever is the missing factors or factor in a particular denominator of a coefficient, that should be its multiplier. So you have here, okay, I recall me asking, you have 6 unknowns that require 6 equations. Okay, so we will assign values to S. That would be easier, or you can also equate coefficients. So let's see which one is easier. I think it's easier to equate coefficients in here because there's no need for us to do expansion that much. So we'll equate coefficients. So we'll have S, or you can assign values if you want, okay? The highest coefficient here is S raised to 5. S raised to 5. If you want to have it expanded, para clear, it's okay. But in here, you could see that you have an S squared. If you multiply it to S, that would be S cubed. If you multiply it to S squared, that would be S to the 5th. So this is A. You don't have S raised to 5 on the right, on the left side. So you have A. I don't have here S to the 5th. Okay. And this is just 4. This is 3. This is another 5. Oh? So D. And this one. S cubed times S, that would be to the 5, and E. Equation 1. So we go to S raised to 4. Left side does not have S raised to 4. There's no S raised to 4 here. Now, if this one is multiplied to this, that would be negative S squared. It's multiplied to this, that would be negative S to the 4th, right? So I will place negative A. Okay, what else? So let's go back. Now, if this one is multiplied to this, that would be S cubed. If it's multiplied to this, that would only be S. This S cubed multiplied to S squared, that would be S raised to 5 already. So, ang atong ding S raised to 4 is isa lang. We have only this one multiplied to this. Okay? Now, in here, we have this S squared times S, that's S cubed times S, that's raised to 4. So, you'll have a B. If this is multiplied to this and this, that's the same thing. If this is multiplied to this and this, that's just an S. So that's it. In here, Joshua, you have here an S squared. If you multiply it with negative 1, that would be negative S squared. If you multiply it with S squared, that would be negative AS to the 4th. That is why it's negative. Okay. Where was I? So I'm on the B, S to the 4th. So 2, 3, 4. For this one, it could never be S raised to 4 because it can only have cube here. This one can only have cube because this is S raised to 5th. This one will be this one. S cubed times -1 is negative S cubed times this one is negative S to the 4th E. This one. S to the 4th times -1, that's negative E. Okay? We are looking for the S to the 4th. Okay, ini siya, i-multiply mo, d cube lang na, i-multiply mo, di ma-4th na siya. So, amo na siya. Kung i-multiply mo siya sa tanan, ma-5th siya. So, hindi pwede. Okay, so we go now to S cube. You can also check the manner we equate coefficients. So, we'll have 15 now on the left. And in here, you have this one is S squared times S, that would be S cubed times 4, so that would be 4A. Another one is we have negative S squared, negative S to the 4th, that's not it. And this one is S squared only. So we only have S cubed in here. Let's say this S cubed, S to the 4th. This, okay, this one S squared, S to the 4th. This one is 4. Okay, so we only have one S cubed in here. In here, you have your S cubed in here, class, will be this one, the -1 and the S squared. So negative S squared times S, so that would be negative B. I'm equating S cubed. Okay, that one S cubed. This one S lang. Okay, that one S to the 4th. So, okay. So, this one, your S cubed would be the C itself. S and S squared. So, that would be the C. In here, this one, the D, but it should have 4. And that's it. In here, we have negative S cubed times F, so negative F. Here, this one will be S to the 4th, and this one would be S to the 4th, S to the 5th. This one, S to the 4th, S to the 4th. So that's it. We only have one. Next is we have S squared. So you can also assign values if you want. S squared we don't have. So 0 again. Let's see. S to the 4th. F, S to the 4th. Yes, F. Yes, we have an F. I don't have an F. Ah, okay. Thank you. So we'll have an F here. For S squared, you don't have on the left. In here, we'll have -1 and 4, -4. This one, so -4A. S squared. Okay? Hindi naman na siya mag-S squared dira. So there will have B and this 4 here. So 4B. Okay, we'll have 4B here, whereas this one squared. This one negative S squared, negative S cubed, -4, 4 times S negative 4S. So only one here for S squared. Negative S squared negative B. Wait. I'm looking for S squared, by the way. So I should only have this one for B. Okay, S squared multiplied to this 4B. Okay, I have that already. Then in here, I have 1. That's negative C. Negative C here. This one, none. Because that's cube. This one is 5th. This is 4th. This is cube and this is 4th. So none for the F. Then we go to the S. 16. Negative. And S. So we can never have an S here because of this multiplier. So wala tada S. Ini times this is negative S times this negative 4B. Okay, class, I'll stop share ko anay. Okay, I cannot move to the next slide. S here is, you have here negative 4B. Okay. For the C, we have this. CS times 4. 4C. Here, it can never be. In here, di pwede. Kaya may S cube ka. So, we only have an S. So, hindi pwede. Okay, last would be the constant. In this case, your constant is 16. Constants. We can have constants here. We can't have constants here. Here we can. We have negative 4. C. Here, hindi pwede. There hindi man pwede kay may SQ. Okay, so the only constant that we have is in here. You have multipliers here, so it cannot be. So from here, we get to know that C is equal to negative 4. Here you can get B. Can you solve for B? You have negative 16 plus 16, 0. B is 0 from here. Because this would be negative 16, transfer here 0. Here, if you substitute, what is the answer for A? If B is 0 and C is negative 4, so 4A is negative 1. Here, 0. So negative 4, that would be positive. Oh, negative 4. So C, so positive 4, transfer it here negative. Oh, it's positive 1. Not negative 1. So we have 1. And what else? We have A, B, C, A, B. Okay, I have A and C. Sige. So we'll have to assign equations here. So this is equation 2 and this is equation 3. We know already the 3, so we can substitute A to 1. So that would be negative 1 is equal to D and E. I'll transfer it here. So equation 4. And if we substitute 1 here and b here, so you will have 1 is equal to negative e and f. So I substituted 1 and 0 for a and b here. So positive 1, 0. So negative e plus f. Negative e plus f. Here and in here, if you substitute 1, that would be 4. Here, minus, you subtract 4 from 15, that would be 11. This is 0. 11 plus 4, because this is negative, that's 15. So 15 4d minus f. Okay, let's see. Go back, ha? So you'll have 16. Oh, sorry, 15 here. This a is 1, so you subtract 4 minus 4. This b is 0. This c is negative 4, so transfer it here. That's positive 4. And that's it. So it's still 15, and what you have left here is 4d minus f. Okay? Now from here, you can solve for the unknowns. You can add 4 and 5. So you have negative 1 is d plus e. Then you have 1 is equal to f minus e. I just interchange it. So if you add, this will be 0 equal to d plus f, right? Because this also will be 0. So d is equal to negative f. So go here, you have 15 is equal to 4. Your d is negative f minus f. So you have 15 is equal to negative 5f. So f is negative 3. D is 3. Yeah. D is 3 from here. The negative of negative 3. And E, you can substitute anywhere. So E, from this one, if D is 3, E is negative 4 here. If D is 3, transfer it here, that would be negative 4. So you already know the 4 coefficients, A, B, C, D, E, F, from here. So you can have these partial fractions inverted. Okay? Sige, we'll do it piece by piece. So our y of x, the solution of our dE is the inverse Laplace of. So for our a has a value of 1. And the partial fraction is 1 over s. So I'll place here 1 over s. It's 1 here. B is 0. If I'm not mistaken. B is 0. So meaning we did not process this. So we'll go to c over s cubed. Your c is negative 4. So you'll have negative 4 inverse Laplace of 1 over s cubed. Okay? Your d is 3. And what is that d? This one. S minus 1. So 3 plus 3 inverse Laplace of s minus 1. Okay? What about the e is negative 4, and this is it. Okay? So I'll place here negative 4, and I'll have inverse Laplace of s over s squared plus 4. Kin split ko, I split it. Okay, the e here is negative 4. And f is negative 3. So the same denominator. Oh, sorry. Negative 3 inverse Laplace of s squared plus 4. So I did not place any constant here because we have the rule that if it is a constant that should be written in the numerator of a denominator which is an s squared plus a certain number, the constant here should be the square root of this number to bring about a sign. So I should place here a 2 and I place here a 2 outside, 1/2, that is. So if you'll have this inverted, you already have the solution of this DE. The inverse Laplace of 1 over S is 1. Now this S cube tells you that your N here is 2 because this 3 here is N plus 1 already. So you need to place here a 2 factorial, multiply it to 2 factorial, and you divide here by 2 factorial. So in effect, you will only have 4 divided by 2 factorial, that should be 2, and 2 factorial over S cube is T squared. If you take the Laplace of this, that would be 2 factorial over S cubed. So we always write down our function of S in a manner in which it's readily invertible. Okay? In here, you will have a plus 3 e raised to t. If you take the Laplace transform of this, it would be this one. For this one, this is a cosine. The omega or the alpha is the square root of the constant here. So it should be minus 4 cosine of 2t. The 2 here is taken from here. This one is a sine because it's a constant here equivalent to the square root of the perfect root here. So you have minus 3/2 sine of 2t. Oh, I keep on writing t. It should be x because we are now writing the solution of our DE, which has the variable x, not t. So this should be an x, this should be an x, this should be an x, this should be an x. This is the solution already. You have any questions? You need to look into the other pages of the Jamboard. Okay, check ko ha. This ang last nga negative 3/2. Paano, Miss Man? This one, I'll erase first. You don't have the 3/2 there originally. You don't have the 2 here. If you need to have this inverted, and you have a square of an s and a constant here, the numerator should be a constant to make it a sign. And that constant should be the square root of the constant here in the denominator. And that constant should be 2. So since we introduced here a 2, you have already altered the entire expression. So you divide by 2. You get it, Joshua? Okay. Para mag-perfect ang function of S mo, kaya hindi siya ma-invert kung hindi na siya that 2. Kung 1 da, kinalan mo, hindi na siya 2 para mag-sign siya. You know if you're doing it the right thing because kung kwaon mo ni ang Laplace, ang imo ginanswer, mabalik na di siya ho. Ti ang original mo 1, so kinalan mo gina siya 2. Kung ano ang square root sang constant nga gin-add sa S squared sa dalom, amo na siya dira ang ara sa babaw. Some more questions? Okay. So the tedious process in Laplace transform is actually in finding the value of these coefficients, especially if you have a combination of functions on the right side for non-homogeneous DE. Galawig siya depending on the function that is written on the right side and also depending on the initial conditions provided in the problem. Okay? Some more questions? I hope this will help. Your exam, I am sure you have checked already. I think it's on the 4th. Okay. But nonetheless, you have any questions here?